Hi everyone. Day 16 today. We're looking at file input output functions, part 2. We're also going to look at datetime along with operating system, and we're going to look at random. We're going to try and generate some data and write it into a file. Right. So that's what the plan is for today. So what we did with file input output is we imported the OS module. We did the current working directory, which was the get cwd function that is a built-in operating system. Right, we set the current directory path to our OS path ABS file function, which tells us exactly what current file we're on. So and then we fed that into the directory, and the directory takes with that argument of the file name, right? So it goes through, it scans the operating system file directory, looks for the current file, and then prints out, and you pass that to that file name, and it creates that object. Then we create an output folder, which is right here, that you can see, and then we did a Boolean check to see if it was true, if that directory actually existed. Then we created a file path with this day 15 data inside it, and we printed it. And then the first write function went looking for this file path. It used the W keyword, which indicates to the with open function in writing files that we should write this file. We're going to call it output file. Output file is the function variable that you can call operations on, like write. We call write line 1 and line 2 and line 3. With append, we use append to add a line towards the end of the list of the file, right? So that line 3 right here that you see is the append function does that, right? When you use the keyword R, you're basically just able to read file. Those are the operations, so you're not able to write to the file. When you do R plus, you can read a file, and then you can overwrite everything in the file and use the write function and delete everything in the file and put new data inside. And then we do 0, 1, 2, 3 right there, right? We can do that. So that's what we have so far. So let's create a new file really quick. Let's go day 16. Pi right there. And let's copy over some code from 15, like this directory structure a little bit over here, right? So let's copy that over into 16. Let's save it and run it and see what our output is here. Right, so we're able to get, I should put our link over here. Chat. That's the GitHub, so that you guys can get the code, right? Right. So if you look at the debugger really quick. Let's look at our current working directory, right? So that'll give us our cwd. We should just start. We could do os dot get cwd like that to print out what we have, right? So, and then current directory is this file name right here. Right, so that should print out our file name. Okay. Move the mouse out of the way. That's your current file name. So that's our current directory. So our directory is only up to basics, right? So this is saying, hey, what's the path of the file, of the current file that we're working in? But we want to pass this object. So let's go to home. Let's just call it object A, right? We want to pass that A into os.path .dir name, this one. And then we want to go in here and pass A. And then that should put out the actual folder structure of Python basics, right? So then when you have that, you then join current directory over here and you add output to it. So it'll be workspaces Python basics and slash output. So we create that output path. So output path has the output concatenated towards the end right there. This is a Boolean check right here saying, hey, check and see if this folder actually exists, which is true. If not, it would give you an error, right? And then it does file path. So we create this file path object, and we just name the file before the actual file is written or created. So you can actually go in here and you can go into output and you can delete this file, right? And it's gone, right? But when you run the program, it just says, hey, it just creates this object saying, see, there's no error or anything that it couldn't find it, because all it's doing is saying, hey, just check for this right here, right? That's all you need to really do. Right, so we have file path as well. So we got the file path and we have everything set where file number 16 is running and it's putting out information, right? So we can, and instead of calling it data, we can call it part 2 or part 2, right? So if you go over here and you rerun this, it's going to write a file inside here, inside output right there with all this information in it. Now inside the output folder, we're going to write the second file over here called part2.txt when we do the write operation, right? When we do the write function, we're going to write some more fresh data in here, right? So let's go over here. Let's take the write call over here as well. That. Let's go over here. Let's paste it right in there. We can say day 16. True. W mode. Line 3. This file will have the readline, readlines, random, and datetime. Functions. Okay. Save that. Now, because we've given this file path over here, it should create a new file in here when we run day 16, the file, right? So we ran day 16 and there's the new file. And those are the lines that we just put in there that it should write to them, right? So that's our write right there. So let's try and generate some data now. So this is a way to write like an individual line, right? But let's say we want to put some number in, right? So what we need to do is let's import the random module, right? Which is another Python built-in. Okay, and what it says, it's a random variable generator, right? It creates integer sequences, you know, and a host of data, right? Uh, and it says it used the Mersenne twister code generator underneath under the wraps, right? So that's what it uses. So let's start with making a few lists, right? So let's make students, right? And let's put a couple of students in our list. Let's put me. Let's put Sean. Let's put Jason. Let's put Michelle, right? 1, 2, 3, 4. Let's put I'm going to J-O-N, but John is fine. All right, so we have students. Let's do programs. Let's do AIML. Let's do MESS. Let's do ME. Let's do electrical engineering. Let's do, oh, that's enough. So that's 4 programs, right? /T gives you a tab, right? Program. Score. Stamp. Let's give it a new line, right? So we go for score range. Range in 10. No, why is it giving me a hard time with range, with the range function? For underscore code in range. Come on, man. So we have these three objects, right? So we want to create a name. Let's try and create a name, right? So we go random, and then we go choice, right? And then we pass in our students. So it's gonna pick a student, right? And then we go programs or program, sorry. We go, and then because we're already using programs, we can't use it twice. And this is not inside a function, it's on the global level, so there's going to be a conflict there. Right? We don't want to create a race condition. So we go random dot choice, right? And we go in here and we say, we feed in programs, right? So we got the name, we got the program, we got to do score next, right? So what actually we did not create so we didn't create an object up top, so it's not gonna go random range twice random. Let me check how to do random numerical generation. Random Python num generation. I want to give the score between 0 to 100, no? Let's try 2 to 4. NumPy. I don't want to do NumPy, man. What if Python random using random number? Random. Right, so there's an external library that you have to do a pip installation for to do this, to accomplish a random number between a range called NumPy, right? So you can do that, or you can do random uniform and 2-4. So you can give score equals to random, and you can feed this in here and go random uniform. From what I'm thinking here, you go random dot uniform. There it is. Let's see what it does again. UNI. There you go. Uniform takes a b float, and then outside it takes a float as well, right? So uniform, you want to give two values in here. So we give 2.0, 4.0 because they're floats. Remember what they said in the description for it, right? That put a float. See, A float and B float, and get a random in this range between 2 and do I want to between 2 and 4? Yeah, GPA, right? So between 2 and 4. So I have to put one more number in here. I don't know what to put. Why should I put it? What does the second number mean? That's the syntax of it. Okay. So we need to put 2 in here, like that. All right, my friends. Let's see. No. Where'd it go? This, random. Syntax is correct. Round random dot uniform, boom, like that. 2.0, 4.0, 2. Huh, there's a comma in here. Okay, so the syntax, there's a comma in here. So in here, it doesn't say it in here, but you have to give it. So get a random number between AB and BA, depending on the rounding, and you have to give no expected value. So we need to round it, and we need to give that the number has to be 2 digits or 2 spots. That's what it is. And then we can do timestamp because that's the last thing we want to do. Stamp, not stand. Stamp. Take that right there. Take that. Take that, computer. Take that. We'll do lowercase because just because. So, okay, how to generate a timestamp for now. Timestamp in Python. Okay, so first let me do the random for you guys. So random Python. Here's the random that I got. The link. That's random. And that is generated. Current time. Okay, so you do a current time object, and then you run a string format time. Okay, so this is literally it. So current time is equal to date time. So date time dot now. Boom, just like that. Why is it not doing date time? Oh, I have to import it in here. Import date time. Boom, just like that. That should do now. And the timestamp is equal to current time dot string. Huh. Let me just put this over here. Put this piece of code right there for you guys really quick. This is where it's from. Boom, just like that. That's what it is. So this thing right here needs to be copied because that will take the entire like that. That's the timestamp. Year, month, date, hour, minute, second, with a modulus inside it, and it's all inside a string, right? So that'll stringify the time into this format, right? So that's what we want, and that's from, here we go, Geeks. They have GMT as well. There's quite a bit you can do with this. So definitely use that resource, and then use this is the correct way to do it. right? This Pi native has really good examples of this epoch. Current timestamp and then format it. What is the timestamp? Get the current timestamp. And then use datetime, DT, GMT. Yeah, look at this convert timestamp to string. So take a look at this. What? I didn't want to copy the whole thing. I wanted to copy the link. Well, just look at the link. This is the link. Probably better. Anyways, so you can find that link and take a look at that. It literally has this exact same line and an explanation of how to convert, how to use this, right? It's somewhere in here on top in the text. You'll find it, but I put it specifically over here. Like this is the exact code we want to use. Anyways, so once you have this, think about what you're doing, right? You're building a print statement that you want to write into the file. So you want to pick a random student, pick a random program, round up random GPA for their score, and then pick a random time as well, and pick a random timestamp. So if you have all of that, what you can do is you can go lines.append, boom, just like that. In range, we can go f string, and we can go how many? 4 of them. There's 4 variables, so 1, 2, 3, 4. Name, program, score, timestamp. It has to be in the same. Did I put a new line character up top? So I put a tab after the first one. Okay, so it has to be in this exact same format as lines is on top, right? Because you're appending this information up here. So the first object has to be name, right? And then if you notice up top, like there's a /t, so you have to give a tab in here as well, right? And then you go in here and you can do program, right? And then you give us tab, and then you put in score. And then you put in another tab. And you put in timestamp. And then you put a new line. Right, so what's going to happen is the line is going to have a name of a student, then going to give a tab. Then it's going to give the program, then it's going to give a tab, then it's going to give the score, then it's going to give a tab, then it's going to stick a timestamp, and then there's a /n, so it's going to go over here to the new line, right? So it's going to do that. That's what we wanted to do anyways. Over here, and then we want to, okay, and now because this is global, this is going to run, this whole loop is going to run 10 times. So when you run this, it's going to just append this lines list and make it like huge, right? So you can print lines, print lines, like that. We also want to append it, right? So what we do is with open, with open, and we give it file path. We want to append, right, as file. And what are we going to append, right? So lines. We want to create this lines object, and we want to go file dot up. I don't want to append. Is it file dot append? It has to be writelines. And what are we going to pass? We're going to pass in the global lines, and we're going to say, we're going to call this writelines, right? Just like that. So this should print out what we have for lines, and then it should write it into the file too. Right now the file has these 3 lines in it, right? So if you go up here, we save this, we should see this printed out, this particular format over here, and then append should go towards the end of those 3 lines. And so every time you write it, you're appending it, appending it, appending it. So it's going to keep adding it to the end of the file, right? Why is datetime now not working? Datetime like that. Current time is daytime now. This is not incorrect. Daytime dot. Oh, I know what happened, man. Daytime dot. Really? Daytime dot now, not max, now. That is long. Worked. Okay, it worked. So check it out. So you have this information that was generated, right? If you run this again, it'll just keep appending it. So every time you run it, 3 times you ran it, it should just. Why does it not append it? Append to file. Oh, because it's rewriting the file, right? So it's going through this entire thing over here, and I'm pretty sure the file is getting read lines, write lines. Yeah, the write lines is going over the stuff. It's not appending it. So if you run the append command with write, then let's try this with write. I'm trying this to see if it'll append it. It can only append 1 line. Okay, so write lines obviously wipes it and re-puts it in there. Like that. Okay. I'm gonna check this really quick on my Google. Just want to make sure that this write lines. Okay. So write func on append. Okay, Google it. The behavior of write lines does not depend on whether you use write or write lines. It entirely depends on the file mode that you select. So if you pass a string, it'll pass it, or write lines is a list of strings without adding new lines. But neither function controls overwriting or appending. Okay, this should append. This should not. String. We're gonna pass the string and that's what it did. Okay, so you can see that it is over and over and over adding it, right? So the reason it's doing this, let's look at my name and see if it's there multiple times. I know, I have a sneaky suspicion. Okay, so it appended it multiple times because it ran multiple times, right? You have to pass it in as a string. If you don't pass it in as a string, it'll overwrite that block because you're passing in a list, right? So as long as it goes in as a list, strings as a list, it's going to overwrite it, and that's really strange behavior, but that is the behavior. What I've discovered. So if you typecast it to a string, from a list of strings to a string of strings, then it'll put it in there over and over again, right? And append that. So that's what I found. But I can just double check this anyways. So double check if append writelines does in fact append to end of line or overwrite the contents the text file. Great. So let's check this. Let's put this in here. I will double check this. All right, cool. So we got a generation of data in here. So the main thing that we did is we're able to create this extra set of information. What we're going to do is we're going to see if the append will start adding it to the end. I will cross-check that to make sure that I'm not making a mistake and giving you guys wrong information. But that's pretty much it, I think, as far as append goes. And the R, we already looked at R and R plus, which is reading, and R plus was reading and writing. So we looked at those. So we're all set with reading and writing operations. I don't have anything else as far as this goes. I will double check this and we will look into it tomorrow. Thank you very much. Have a nice evening.